Deep in the Sahara Desert, there are rock formations that defy every geological explanation you've ever been taught. Structures with rings so massive that standing at the center you cannot see the edge. Annual growth rings, 200 feet across. And if those are annual rings, the tree they came from would have been miles tall, not hundreds of feet. Miles. The kind of tree that would dwarf the tallest redwood the way a redwood dwarfs a daisy. But here's what makes this even stranger. These formations are not isolated freaks of nature. They are everywhere, scattered across deserts, plateaus, and mountain ranges on every continent. Always the same hexagonal structure, always the same concentric rings, always dismissed by mainstream geology as natural columnar basalt or sandstone erosion. But when you start connecting the dots, you realize something catastrophic happened to this planet. Something that turned forests of titans into the stone monuments we mistake for mountains today. If you want to understand what really shaped the world you live in, hit subscribe. This channel covers the history they don't teach, the geology they can't explain, and the evidence hiding in plain sight. Now, most people have heard of petrified wood. You've probably seen it in museums or gift shops. Small logs, maybe a few feet long, turn to stone over millions of years. The process is well understood. Organic material gets buried under sediment, mineral-rich water seeps through, and over time the wood's cellular structure is replaced molecule by molecule with silica or other minerals. What you end up with is a rock that looks like wood, preserves the grain, even shows the growth rings. Standard geology. No controversy there. But what we're talking about in the Sahara, and in dozens of other locations worldwide, is something orders of magnitude larger. Structures that, if they are petrified trees, suggest an Earth radically different from the one described in textbooks. Let's start with the specifics. In the Sahara, particularly in regions of Algeria and Mauritania, there are circular rock formations that display unmistakable concentric rings when viewed from above. Some of these formations measure over 400 feet in diameter. If you apply the basic principle of dendrochronology, the study of tree rings, and assume these rings represent annual growth, you're looking at a tree stump with a diameter of 200 feet or more. To put that in perspective, the largest known living tree by diameter is a giant sequoia in California called General Sherman. Its base diameter is about 30 feet. The Sahara formations are nearly 7 times wider. And if we're talking about stumps, that means the trees themselves, before they were cut or fell, would have been exponentially taller. We're not talking about trees that were twice the height of a sequoia. We're talking about structures that could have reached several miles into the sky. Now, the mainstream explanation for these formations is that they are not petrified trees at all. They are volcanic rock structures called columnar basalt, or erosional features in sedimentary rock. Columnar basalt forms when lava cools and contracts, creating hexagonal columns. You see this at places like the Giant's Causeway in Ireland or Devil's Tower in Wyoming. It's striking, geometric, and completely natural. The Richat structure in Mauritania, also known as the Eye of the Sahara, is often cited as a prime example. It's a massive circular formation about 30 miles in diameter, with concentric rings clearly visible from space. Geologists say it's a deeply eroded dome, a geological bullseye created by the uplifting and erosion of sedimentary rock layers over millions of years. No trees, no mystery, just geology doing what geology does. But here's the problem. If you actually look at the Richat structure and you look at petrified wood under magnification, the patterns are nearly identical. Both show concentric rings, both show radial fracturing, both show hexagonal segmentation at certain scales. And when independent researchers have gone to the Sahara to examine these formations up close, they've found something the textbooks don't mention: silica content. High concentrations of silicon dioxide, the same mineral that petrifies wood. Some of the rock samples taken from these formations show cellular structures under microscopic analysis, structures that look an awful lot like fossilized wood grain. Now, this hasn't been published in peer-reviewed journals. You won't find it in Nature or Science. But the people doing this research aren't cranks with metal detectors. They're geologists, engineers, and independent scientists who started asking questions that didn't have satisfying answers. So let's assume, just for a moment, that these formations are petrified tree stumps. What would that mean? First, it would mean Earth once supported trees of a scale we can barely comprehend. Trees with trunks hundreds of feet wide and crowns that reached miles into the atmosphere. The amount of sunlight, water, and nutrients required to sustain such growth would suggest an atmosphere far denser than what we have today. Perhaps higher oxygen levels, which would also explain the gigantism seen in other fossilized life forms from earlier geological periods. Dragonflies with 2-foot wingspans, millipedes 6 feet long, ferns the size of modern trees. The fossil record is full of evidence that Earth once supported life on a much grander scale. But trees miles tall, that's where mainstream science draws the line. Because if trees that large existed, it would require us to rethink everything we know about Earth's history, its atmosphere, and the events that shaped its current form. And that brings us to the second implication. If these are stumps, then something cut the trees down, or knocked them over, or burned them to ash, leaving only the stone bases behind. This is where the revisionist history comes in. There are researchers who believe Earth experienced a planetary scale cataclysm, not millions of years ago, but within the time frame of human history. An event so destructive that it reshaped continents, buried entire civilizations, and turned living forests into stone. Some call it the Younger Dryas impact event. Others tie it to ancient flood myths found in nearly every culture on Earth. The core idea is the same. Earth was reset, and the giants, both biological and architectural, were wiped out. Now, before you dismiss this as pseudoscience, consider what we know about Earth's magnetic field. It flips. Periodically, over the course of hundreds of thousands of years, the magnetic poles reverse. North becomes south, south becomes north. During these flips, the magnetic field weakens significantly, which means Earth's surface is exposed to higher levels of cosmic radiation. This could have catastrophic effects on the atmosphere, weather patterns, and life itself. Some researchers believe the last major geomagnetic reversal coincided with the extinction of megafauna and the collapse of early civilizations. And if the atmosphere was destabilized, if the protective magnetic shield was down, massive fires could have swept across the planet, incinerating forests and leaving behind only the mineralized stumps we now mistake for natural rock formations. Let's zoom out for a second. The Sahara isn't the only place where you find these formations. Devil's Tower in Wyoming is one of the most famous examples. It's a massive column of rock rising over 1,200 feet above the surrounding landscape. According to the National Park Service, it's a volcanic plug, the solidified core of an ancient volcano that was exposed after millions of years of erosion. But look at it. Really look at it. The hexagonal columns, the vertical striations, the way it rises from the earth like a trunk. Now, the standard explanation is that these columns formed when magma cooled and contracted, creating the hexagonal fracture patterns we see in basalt. But here's what doesn't add up. The columns at Devil's Tower are remarkably uniform in size, ranging from 4 to 8 feet in diameter. They run vertically for the entire height of the formation, over 1,000 feet, without significant deviation. That level of uniformity is rare in natural basalt formations. Most columnar basalt shows variation, branching, and irregular jointing. Devil's Tower doesn't. It looks manufactured, or grown. Indigenous legends from the area describe it as a tree stump. The Lakota people called it Bear Lodge, and their stories say it was once a tree that grew to save children from a giant bear. The bear clawed at the tree, creating the vertical striations we see today. Mainstream geologists laugh this off as mythology, but what if the myths are memories? What if the stories passed down through generations are distorted, but rooted in something real? There's another detail that gets overlooked. The base of Devil's Tower is surrounded by a debris field. Massive boulders, some weighing hundreds of tons, scattered in a rough circle around the formation. The official explanation is that these are pieces that broke off due to erosion. But erosion doesn't create debris fields with that kind of pattern. Explosions do, catastrophic events do. If Devil's Tower was once a living tree, and if it was subjected to intense heat or a shockwave, you'd expect to see exactly this kind of debris pattern. There's another formation in Russia called the Putarana Plateau. It's a remote, heavily eroded region in Siberia, and from the air it looks like a graveyard of stumps. Flat-top mesas with hexagonal fractures surrounded by what looks like broken root systems radiating outward. Russian researchers have documented these formations extensively, and some have gone on record saying they don't match any known volcanic or erosional process. The rock composition is wrong, the scale is wrong, and the patterns, when analysed statistically, show too much regularity to be random. They look designed or grown. Then there's the Deccan Traps in India, a massive plateau of basalt covering over 200,000 square miles. Geologists say it was formed by one of the largest volcanic eruptions in Earth's history, around 66 million years ago. The same eruption that may have contributed to the extinction of the dinosaurs. But if you look at satellite imagery of the Deccan Traps, you see the same circular patterns, the same concentric rings, the same hexagonal segmentation. And in some areas, the basalt is so rich in silica that it resembles petrified wood more than volcanic rock. Indian geologists have noted this anomaly but have no explanation that fits the volcanic model. And it's not just deserts and plateaus. There are formations in the ocean. Underwater seamounts with flat tops and vertical sides, covered in hexagonal columns. These are called guyos, and the explanation is that they were once volcanic islands that were eroded flat and then sank as the ocean floor subsided. But some of these guyos have rings, concentric circles visible in sonar imaging, and the rock samples taken from them show the same high silica content, the same cellular structures under magnification. Could these be the stumps of trees that grew on a very different Earth? Let's talk about scale for a moment. If these formations are stumps, and if the trees they came from were proportional to the stumps we see today, we're talking about trees that were several miles tall. That's not an exaggeration. If a stump is 400 feet in diameter, and you apply the same height to diameter ratio as modern trees, you're looking at a tree that was at least 2 miles tall, possibly more. The tallest tree alive today is a coast redwood in California named Hyperion. It's 380 feet tall. Impressive, but nowhere close to the giants we're describing. Now, the argument against mile-high trees is simple. They couldn't exist. The structural limits of wood, the weight of the trunk, the distribution of water and nutrients, all of it makes such trees physically impossible under current atmospheric conditions. And that's the key phrase. Current atmospheric conditions. There's a growing body of research which suggesting Earth's atmosphere was once much denser. Not just higher oxygen levels, but higher atmospheric pressure overall. This would have allowed for much larger life forms. It would also explain why insects were so much bigger in the past. Insects don't have lungs. They breathe through tiny tubes called spiracles, and their size is limited by how efficiently oxygen can diffuse through their bodies. In a denser atmosphere with more oxygen, insects could grow much larger. We have fossil evidence of dragonflies with wingspans reaching 30 inches, millipedes over 6 feet long, scorpions the size of modern dogs. These weren't anomalies. They were the norm during the Carboniferous period, roughly 300 million years ago, when oxygen levels were estimated at 35% compared to today's 21%. But even that doesn't fully explain the scale we're talking about with these tree formations. For trees to grow miles high, you'd need not just more oxygen, but significantly higher atmospheric pressure, double or triple what we have now. And here's the interesting part. If atmospheric pressure was higher, water could be transported to greater heights through capillary action and root pressure alone, without the biomechanical limitations we see in modern trees. The same principle applies to structural integrity. A denser atmosphere would provide more buoyancy, more support for vertical growth. Think of it like the difference between building a tower in air versus building one underwater. The surrounding medium matters. If Earth's atmosphere was 2 or 3 times denser than it is today, mile-high trees wouldn't just be possible. They'd be inevitable. The question isn't whether such trees could exist. The question is, what changed to make them impossible now? So what happened to that atmosphere? And what happened to the trees? The most plausible explanation, if you accept the premise, is a catastrophic event. Something that stripped away a significant portion of Earth's atmosphere and incinerated or toppled the giant trees. There are several candidates: a massive solar flare, a nearby supernova, an asteroid impact, a geomagnetic reversal that weakened Earth's protective shield. Let's examine each one. A solar flare of sufficient magnitude, known as a coronal mass ejection, could strip away portions of Earth's atmosphere if the magnetic field was already weakened. We know this happened to Mars. Mars once had a thick atmosphere and liquid water on its surface. Then its magnetic field collapsed and solar winds stripped the atmosphere away over millions of years. But what if a similar process could happen much faster? If Earth's magnetic field weakened during a geomagnetic reversal and a massive solar flare hit at the same time, the atmospheric loss could be sudden and catastrophic. The trees would be exposed to intense radiation. The heat alone could ignite global wildfires. And without the protective atmospheric pressure, the trees would no longer be structurally viable. They would collapse under their own weight. An asteroid impact is another possibility. The impact that killed the dinosaurs released energy equivalent to billions of nuclear bombs. The shockwave alone would have toppled anything standing. The fires that followed would have burned for months, and the debris thrown into the atmosphere would have blocked out the sun, causing a global winter that killed off most plant life. If an impact of similar or greater magnitude occurred more recently, it could have had the same effect on the giant trees. The impact site might be underwater now, or buried under ice in Antarctica, which is why we haven't found it. Or it could be staring us in the face, misidentified as something else. There are impact craters on Earth that are far larger than the one that killed the dinosaurs. The Vredefort crater in South Africa is over 200 miles in diameter. The Sudbury Basin in Canada is even larger. Both are billions of years old according to current dating methods. But what if those methods are wrong? What if some of these craters are much more recent than we think? Now, let's address the elephant in the room. Why would this information be suppressed? If there's legitimate evidence that Earth once had mile-high trees, why isn't it taught in schools? Why isn't it front-page news? The answer, according to revisionist historians, is that it would unravel too many established narratives. It would challenge the timeline of human history. It would force us to reconsider the capabilities of ancient civilizations. And it would raise uncomfortable questions about what else we've gotten wrong. But there's more to it than just academic embarrassment. The scientific establishment has a vested interest in maintaining the current paradigm. Careers are built on it. Funding depends on it. Universities don't give tenure to professors who challenge foundational theories. Journals don't publish papers that contradict decades of accepted research. Think about what would happen if this theory gained mainstream acceptance. Geology textbooks would need to be rewritten. The entire fossil fuel industry, which is predicated on the idea that coal and oil come from ancient organic material compressed over millions of years, would face scrutiny. What if coal isn't ancient forests? What if it's the remains of these giant trees compressed and carbonized in a single catastrophic event? That would mean our estimates of how much fossil fuel exists, how long it took to form, and how long it will last are all wrong. The economic implications alone would be staggering. And then there's the historical angle. If Earth was reset within the last 10,000 years, it means advanced civilizations could have existed before recorded history. Civilizations that had technology, knowledge and capabilities we can't explain. The pyramids, Göbekli Tepe. The underwater structures off the coast of Japan, all of these could be remnants of a pre-cataclysm world, And if that's true, it means human history didn't start with primitive hunter-gatherers. It started with something much more advanced, something that was lost. But the evidence keeps piling up. In 2016, a team of independent researchers published a detailed analysis of the Richard structure using LiDAR and ground-penetrating radar. What they found was a subsurface network of radial and concentric features that don't match any known geological process. The patterns looked biological, like roots, like a vascular system. Mainstream geologists dismissed the findings as artifacts of the scanning process, but the researchers stood by their data, and when they tried to publish in peer-reviewed journals, they were rejected, not because the methodology was flawed, but because the conclusions were too controversial. There's also the issue of dating. Petrified wood is notoriously difficult to date accurately because the organic material has been completely replaced by minerals. Radiocarbon dating doesn't work because there's no carbon left. And radiometric dating of the surrounding rock only tells you when the rock formed, not when the tree was petrified. So we're left with estimates, educated guesses. And those guesses are based on the assumption that the formations are natural, not biological. If you start with the assumption that these are volcanic or erosional features, you'll interpret the data accordingly. But if you start with the assumption that they might be petrified trees, the data looks very different. Let's circle back to the Sahara. The reason the Sahara is so important in this discussion is because it's a relatively recent desert. Geological and archaeological evidence shows that the Sahara was green just a few thousand years ago. There are cave paintings depicting lush grasslands, rivers, and abundant wildlife. The people who lived there hunted hippos and crocodiles. Then, around 4,000 years ago, the climate shifted. The rains stopped, the rivers dried up, the grasslands turned to sand. And within a few centuries, the Sahara became the desert we know today. This rapid desertification has been attributed to changes in Earth's orbit and axial tilt, which altered weather patterns across North Africa. But what if the desertification was a symptom of something larger? What if the same event that turned the forest to stone also turned the Sahara to sand? There are researchers who believe the Sahara and other deserts around the world are the remnants of a planetary scale fire. A conflagration so intense that it turned organic material to ash and left behind vast expanses of silica sand. If you've ever seen glass made from sand, you know that sand is primarily silicon dioxide, the same mineral that petrifies wood, the same mineral found in high concentrations in the rock formations we're talking about. Could the deserts of Earth be the ash fields of ancient forests? It sounds extreme, but massive wildfires can create deserts. We've seen it happen on smaller scales after volcanic eruptions and meteor impacts. The question is whether it could happen on a global scale. And if it did, would there be any survivors? This brings us to the concept of resets, the idea that Earth has experienced multiple catastrophic events that wiped the slate clean and forced life to start over. This isn't fringe science. The fossil record shows at least 5 major mass extinctions, events where the majority of life on Earth was wiped out. The most famous is the extinction of the dinosaurs 66 million years ago, but there are others. The Permian extinction killed over 90% of all species. The Ordovician extinction wiped out 85% of marine life. Each of these events reshaped the planet, and each time life bounced back. But it came back different, smaller in many cases, adapted to a new set of environmental conditions. What if the same thing happened more recently? What if there was a recent event within the last 10,000 years, an event that modern science has either overlooked or deliberately ignored? The evidence, if you know where to look, is everywhere. Megalithic structures that defy explanation, sunken cities off the coasts of continents, flood myths in nearly every ancient culture. And these rock formations, these petrified stumps scattered across the globe like gravestones marking the death of a world we can barely imagine. Now, I know what you're thinking. If trees that large existed, where are the fossils? Where are the leaves, the branches, the seeds? And that's a fair question. But consider this. Fossilization is rare. Most organic material decomposes completely. For something to fossilize, it needs to be buried quickly in the right conditions, with the right mineral content in the surrounding sediment. If these trees were burned or toppled in a sudden catastrophic event, the branches and leaves would have been incinerated or scattered. Only the densest, most silica-rich parts would have survived, and those are exactly what we're finding. There's also the possibility that we've been finding the fossils all along, but we've been misidentifying them. There are formations in various parts of the world that look like petrified logs but are classified as something else because they're too big, too regular, too geometric. When something doesn't fit the model, it gets explained away. It's columnar basalt, it's a dike, it's a sill, it's erosion, and the research stops there. But what if we're wrong? What if the model is incomplete? Let's talk about one more location. Australia. The Australian outback is full of strange rock formations that geologists struggle to explain. There are mesas with flat tops and vertical sides, just like Devil's Tower. There are circular formations with concentric rings, just like the Richer structure. And there are massive boulders, some weighing hundreds of tons, scattered across the landscape as if they were thrown there by some unimaginable force. Aboriginal legends speak of a time when the land was different, when there were giant trees and giant beings who walked the earth. These stories are dismissed as mythology. But what if they're oral histories, passed down through countless generations, of a time when Earth was radically different from what it is today? The implications of all this are staggering. If Earth once had forests of mile-high trees, it means our understanding of the planet's history is fundamentally flawed. It means the atmosphere, the climate, and the biosphere were all vastly different from what we've been taught. It means there was likely a global civilization that thrived in that environment. And it means something catastrophic happened to end it all. The question is, what was that event? And more importantly, could it happen again? There are scientists today who are warning about the weakening of Earth's magnetic field. It's been declining for the past 2,000 years, and the rate of decline is accelerating. Some researchers believe we're overdue for a geomagnetic reversal, and if that reversal happens, the consequences could be severe. Increased radiation, disrupted weather patterns, widespread electrical failures. It wouldn't be an extinction-level event, but it would collapse modern infrastructure. And if history repeats itself, it could be the kind of reset that leaves future generations wondering what happened to us. So where does that leave us? With more questions than answers. With rock formations that don't fit the standard geological model. With legends and myths that point to something real. And with researchers who are willing to challenge the mainstream narrative, even if it costs them their careers. The truth, whatever it is buried under millions of years of sediment, hidden in plain sight. The Sahara hides petrified stumps with annual rings 200 feet across. If those are stumps, the trees above them were giants, and if giants once walked this earth, then everything we think we know about our past is up for debate. This isn't about conspiracy theories, it's about the evidence. And the evidence, when you look at it without bias, is compelling. Maybe it's time we stopped dismissing the anomalies and started paying attention. The world you live on might not be the world you think it is, and the history you were taught might be missing the most important chapters of all. If you want to keep exploring the hidden evidence they ignore, subscribe. Next time, we're diving into the megaliths they claim were built with copper tools.